All right. Should be live. Maybe, maybe not. Who knows? All right. Hey everyone, how's it going? Sorry about posting the events. I always post at the very last minute. And I'm super disorganized about it, and so I figured, oh, okay, I'll post a whole bunch of events in advance so that then I can figure out what the individual episode is and slot that in. But we've always got like a nice permalink to what the show is, and apparently YouTube spams you in a bunch of different ways. So I had a bunch of people complain. So I deleted all the excess ones. You've just got one. So unfortunately, we will have to deal with me being doing this at the last minute forever. And sometimes, so all the people who were like, "Oh, I never find out about these until the last minute." Sorry, if I try to do it, try to be organized about it, YouTube spams you. To all the people who unsubscribed from me, you made the right call. It was unforgivable, and I hope I've been punished. So, but I went and I deleted all of the other live events, and so I think that should do the trick. But if it doesn't, let me know. I'd be interested. I mean, I have no way to know that these things happen, so I'd be interested to know like all the ways that it all went bunk. Like you got the there was the like I know it went into everyone's subscription feed. There's a whole bunch of live events, but maybe there was like some kind of like, did it post notifications? Did someone from YouTube come and personally tell you about each one of the upcoming live events while you were like in the bath or something? So anyway, I apologize in advance for all of the future mistakes that I'm going to make, and there will be many because I am always trying to break everything all the time. All right. Well, anyway, so no guests this week, and I'm trying to sort of go a couple of weeks no guests, and then a couple more weeks with guests. I've got some cool ideas for some guests. So stay tuned on that. But as always, if there's anyone that you want me to try and wrangle, let me know. I'm super open about it. But be realistic. Like I know you would like for me to get Elon Musk here, and it's not going to happen. I haven't even asked him. If you want to ask Elon Musk and have him come, we'll wait until I have, like Tim Dodd numbers. Then we'll do a something with Elon Musk. All right, but then otherwise, let's go. Let's do your questions all about space and or astronomy, and we will get into it. I'm trying to think what else. Oh, right. We've got another video that we've got that came out. It's coming out tomorrow. The patrons have already seen it, and it's all. Sometimes people say they get sassy Fraser. This is one of those. So the gist. People are always asking me whether I think that people are going to freak out when we find out evidence of alien life. And the reality is that we have found evidence of alien life many times, 4, 5, 6 times. And we were wrong every one of those times, but it's funny to see. We have evidence of how people don't lose their minds when this happens. So I think that we can sort of use that as a judge and go from there. Wayne Hazelwood, the Gateway Project. What do you think? All right, I have not looked into the Gateway Project much. I saw the really cool video where there's this giant rotating ring where starships or BFRs at the time were docking, and it looked great. It looks awesome. I mean, who knows what's possible once we get to a certain level of launch capacity, like say from the Starship. But I mean, right now, when you just look at like what we've got the International Space Station, and it is kind of old, and it is like it's an amazing accomplishment, but it really has the total internal space of like one inflatable Bigelow 2000 module. I think there's like there's pretty close. Like this Starship's going to have a lot of internal space inside of it. So we have to make this transition to get to this point where heavy lift vehicles can consistently launch large amounts of mass into orbit at reasonable costs that can then justify things like hotels that people are going to want to go to, or cryptocurrency, libertarian paradises in space. So I did the math on like an O'Neill cylinder. This is like a regular old O'Neill cylinder. No, like the rotating, that's right. I did the math on the rotating ring that was in 2001, which is kind of like the closest version to that Gateway satellite. And it was like something like 65,000 launches of the BFR. So you'll know we're close to something like that when you see a bunch of other technologies. And the first one is just going to be on orbit resource harvesting. We're going to be able to pull resources from asteroids, or maybe the moon, but probably asteroids. We're going to see some kind of space-based manufacturing where we will be able to actually turn the material that we found in space into structures in space. Then you're going to start to see these big things. But to launch all that stuff from Earth it's just like an enormous amount. And so then the question is like, does it, can you make a profit? Right? What are the economic incentives of putting all that mass in space? Tourism? I mean, you could probably, for the kinds of costs involved, you could have people go to the International Space Station right now, and they would be able to handle the amount of people who could afford to spend time in space. And yeah, maybe or the other way is that we're going to see sort of larger and larger structures over time. But I think like it just, like it's cool, like the graphics are really awesome, and I should definitely talk to them at some point. But, I'm just, it's like the same thing with like the breakthrough starshot. Like people ask me like, is the breakthrough starshot realistic? And like, we know that a laser beam can shoot at a solar sail and help propel it. But we haven't even seen this technology be used here in the solar system, which is sort of like the best place for it. So let's start with there. Let's have some cool technologies that will send solar sails around here in the solar system. And then once we've seen that, then we can start to wrap our heads around what it's going to take to go to the next level to actually go all the way out to another star system, because it is orders of magnitude more difficult. And same thing with a gigantic rotating, like we have never had a single properly rotating space station that has allowed us to test out any kind of artificial gravity. Like there was this one Gemini mission where they rotated and they got like 5.05 gravities or something like that, like just almost nothing, right? So and yet there's been a really great idea to be added to. There's a small version that's like a tiny little centrifuge that could be attached as a module to the International Space Station. You could attach this module, astronauts can go inside and rotate around inside of it really quickly and try to remove some of the effects of being in microgravity all this time. And then there's a larger one called the Nautilus X that could be attached to the space station. And this has also been thought of going to the Deep Space Gateway. And it could very well be that as the launch costs come down, someone's going to come up with a better way to be able to do this, like on a Starship or whatever. And then we're starting to get closer to this idea, but we don't even know. We don't even know what it's going to take. What's the shape? Is a rotating ring going to be the way, or do you need a longer cylinder? There's just so many questions that we just don't know the answer to. So we will have to find out. Falco Online over on Twitch. Wow, I'm streaming on Twitch. How cool is that? Are there materials that can only be produced in space, and is that economical to do so? There are a couple of things that can be manufactured in space. So there's this kind of fiber optic cable. There's like a crystal that you can only make in zero gravity, where if you can actually grow these crystals in microgravity, they are optically pure in a way that allows for fiber optic signals to go really long distances and without a lot of signal. And they've actually got a little machine that manufactures this on the International Space Station as they're trying to learn. And it could very well be that there could be a special satellite that flies up to space and orbits the Earth and manufactures fiber optic cable and then sends the fiber optic cables back down to Earth once they've been constructed. But apart from that, there's not a lot of stuff that you can, I mean, there's not a lot of stuff that you can find in space that you can't find on Earth. The trick is just, it's so difficult to get things from the Earth up into space. It makes so much more sense. You know, it's kind of like saying, you know, are there any, I don't know, are there any foods that will grow in Europe that won't grow in the United States or in Canada? Well, yeah, there's a few, but the reality is, the point is that they're local in Europe, and so they're easy to go, easy to grow, ship to the grocery store, and then you can just pick them up and buy them because they're close by, as opposed to shipping everything across the world, although we do spend a lot of time shipping stuff across the world. Murph 411, what kind of telescope is behind you? That is a 80 millimeter apochromatic refractor by, I forget, Stellar View? Is that right? Yeah, Stellar View. It's got a lot of dust on it, and that's because I get a chance to use this remote telescope down in California, which apparently is back online. It just came back online today. So those of you on Twitch, I will be on Twitch more often, streaming with the telescope. So stay tuned on that. I hope. Yeah, it was just the angle. So yeah, it's a 80 millimeter. I don't have the camera on it right now. I just have a great big 2-inch eyepiece on it. So I use it more for just looking at stuff, although it's got a pretty nice mount. So, but like, once you get to use a telescope remotely, where you're just like sitting in front of your computer and you're controlling the telescope from far away, and you don't even have to go outside, and you can shoot in a really dark skies in the desert where it's clear skies 300 nights out of the year. It's really hard to go back to trying to look in the night sky here in Western Canada when it's pouring rain all the time. So, and on that topic, Michael Sousa asks, what's your opinion on 20 by 80 binoculars, etc.? Yeah, if you want a pair of binoculars, go with, I have a pair, well, you can't see them, but maybe you can, right? Nope, you can't. Anyway, right there, I have a pair of 25 by 75 binoculars. And, you know, if you're interested in astronomy in any way, shape, or form, that should be one of the first things that you buy. They're cheap, right? They're $50 on sale, and they are wonderful. You can see a lot of objects in the sky that you just can't see with your own eyes. And they get and for some objects, they give you a much better view than a telescope. So I highly recommend it. All right. Thanks to all of the moderators who are putting all of the questions into another thing. So when I'm looking up at all of the other questions. So Neil Yu asks, what is the status of B612 Sentinel asteroid tracker? There's no status. So I think I mentioned this in the latest QA about this was the idea from the B612 Foundation, was to put some kind of tracker on a satellite and then use that to find the exact position of an asteroid. And it would be really useful for us to really understand how satellites move. And it's still their proposal. They're still raising money. They're looking for more people to help them get the word out. It's led by astronaut Ed Lu, who's a really dynamic, great guy, has been really dedicated to this. And we've got a great board of directors, and I think it's a really great foundation. So if there's a cause that you want to get involved in, I highly recommend. I'll see if Ed wants to come and talk to me sometime, because I think it's really vital. There are 800,000 known asteroids now. Many are buzzing around the Earth, and we don't know where any of them are. So precisely. And that's why we can't know with any real certainty where things are going to move into the far future. So I love it. Oh, that's interesting. Just some ideas for future videos. I like them. Kugel Blitzer. Could humanity terraform Venus possibly? Maybe some crazy 1,000-year project. We get that question a lot. We did a video on it, terraforming Venus. It's a pretty old video, and I mention it every now and then and sort of reference it from time to time. If we wanted to terraform Venus, we would block the sunlight, like put up some gigantic sunshade at the Earth's the Venus Sun L1 Lagrange point that would block the light of the sun that reached Venus. And then that would essentially, without any sunlight, Venus would cool down to the background temperature of space, which is like the temperature of the, whenever the actual dark side of the moon, right? Whatever part of the moon is in shadow at the time is like minus, I forget the temperature, minus 200 and plus degrees cold. So you would eventually get to a point where all of the carbon dioxide in Venus's atmosphere would snow out. It would just fall out of the sky and snow into these gigantic snowdrifts. And then Venus would have like no atmosphere. And then if you could somehow lock up all of that carbon dioxide with dumping limestone, magnesium, calcium, there's ways that you could sort of lock up all of that carbon dioxide or dig holes and get rid of it, then you could try to fix Venus. But it's just like, it's a monumental it's a project that just boggles the imagination when we even try to think about it. Like, again, back to the beginning of this episode, right? We have one permanently inhabited space station going around the Earth, and it is an amazing accomplishment. It required an enormous amount of money from some of the richest countries on Earth to accomplish this, and that's all we've done so far. So don't hold your breath is what I'm saying. Although if you're going to be on Venus, hold your breath. Also, you'll be on fire. Walid Damouni, can you tweet or name the binoculars textually to help look them? I'll just grab them. Here, hold on. All right. So my binoculars, I am using Celestron Skymaster 15 by 70s. There we go. And they're great. They're a great binocular. I highly recommend them. Like I said, they're not that expensive. You just sort of, whenever you think you're going to be anywhere near space, you take them with you. And there's something really wonderful about using both of your eyeballs for looking at the sky. Like, there's something we get more vision out of using both eyes at the same time. Even if it's they're flat, it's not like you're going to see 3D of stars, but you can still see fainter objects when you use two eyes than if you can one. And try this. Like, look at some text that you can just barely read with one eye, and then try the other one. But then with both eyes, you can suddenly read it, and it's kind of amazing. And it's just one of the advantages of having binocular vision. And so, even if you have a great telescope, most astronomers, almost all amateur astronomers, use a pair of binoculars as well. It's just like it's just like your Swiss Army knife of astronomy. All right. Scott Collins, should we do something like that with the Earth? Build a big sunshade mirror swarm to offset carbon change? Would we use materials from the Earth or a huge asteroid or the moon? If we get to the point that we are having to use these kind of geoengineering projects to offset climate change, we're in a really bad way at that point. If we are launching aircraft that are throwing particulates into the upper atmosphere to try and minimize the amount of sunlight, or if we're trying to put some kind of shade that just blocks some of the visible light, or blocks some of the infrared, but lets some of the visible light through, or spreading glass. I heard this one, spreading glass in the Arctic. Like maybe that would reduce climate change, but Can you imagine all of the unforeseen consequences of tiny particles of glass being put into the environment? We're in a bad way. So it may very well be that we have no other. And I've seen some interesting ideas like using a certain kind of air, like a high altitude aircraft that we don't have, but they could be developed for reasonably inexpensively, and it would only cost a couple of $1 billion a year to cool down the planet and help us get our temperature back in order. But the best thing that we can do, obviously, is to get it under control sooner than later. And unfortunately, we are taking longer than we had promised. And by we, I mean all countries, right? Are taking longer to do it. But there's a bunch of interesting geoengineering ideas, and obviously they make the planetary engineer in me sort of think, oh, that's really cool, to, I don't know, shift the Earth's orbit farther away from the sun, or launch, dump iron into the oceans to try to increase carbon dioxide uptake or whatever. But you kind of know that if we have to rely on some of those, there will be unforeseen consequences on a scale we can scarcely imagine. And so hopefully that's like the last thing that we do. Horizon Brave. If SLS is tragically canceled, I'm going to read your whole question because this will also allow me to provide a life lesson. So Horizon Brave. Hey, Fraser, I actually emailed you this, but I'm curious. If SLS is tragically canceled, what happens to all of the side projects that inspired, like Orion and the Gateway? So first, I do get a lot of emails from people. I actually got a phone call the other night. It was must have been like 4 a.m, and I was asleep, obviously, and there's someone had left a message. I'm like, I was sleeping. So, but yeah, if you email me, I may not get back to you. It's just because I want to try to answer questions publicly as best I can. Because when I can answer a question here on a video, or I can answer a question in a QA, or I can answer a question in the comments, it gives the answer to as many people as humanly possible. While if I just answer questions one-on-one via email, it doesn't scale. And so now I'm at the point where someone asks me a question like, if we find out about aliens, will humanity lose its collective mind? And I'll just link to the video that I'm releasing tomorrow. And so the more of that I can do, the better. But here's your question. So if SLS is canceled, what happens to all the side projects like Orion and Gateway? Yeah, so they're all separate creatures, right? So the Orion is right now the only deep space capsule that's under development by NASA. Obviously, SpaceX has its version, although they've got the Dragon capsule, the Crew Dragon, and it's not designed to go into deep space. So there really isn't a lot of other. I don't know of any other deep space outside of the Earth's atmosphere, like outside of low Earth orbit, that are in the development. So it's kind of the only game in town. And so the Orion module will, the first Orion was already launched. And I think they used a Delta rocket or an Atlas rocket to get it out beyond, out beyond low Earth orbit and back. And they'd be able to fit it onto a Falcon 9 or a Falcon Heavy or something like that. With the Gateway, right, with the Deep Space Gateway, they could build the Deep Space Gateway using various other kinds of spacecraft. The Starship, if it works, would be a terrific way to carry modules of the Gateway up, and they can attach them. But NASA knows that there are other options as well. You can use Falcon Heavies, you can use other stuff. It's like right now, up until this point, before there were options, they were all really locked together. You need SLS so that you can build the Gateway. You need the Gateway because you need to launch something with SLS. You need Orion because you need something that can carry human beings out into deep space. And to launch on top of the SLS, you need the SLS to launch Orion, etc., right? They're all linked and locked together. But now there's options. And those options are now breaking apart these so you can go, well, you know, actually, maybe we don't need the SLS. We can actually just launch Orion on a Falcon Heavy. Oh, maybe we don't need the Orion. We can launch a, I don't know, a Crew Dragon Deep Space Edition, which, you know, doesn't exist yet, but maybe it does. A Red Dragon on an SLS, or maybe we could launch it on an Atlas. So I think that as you get these options and you can mix and match, then I think that's all good, because SLS is like, is the law. It's, you know, the government of the United States has defined that NASA must use the Space Launch System. And so NASA doesn't have a lot of options. And they've come back now, and they're sort of, you know, now that other launch platforms exist, they're starting to push back and provide some other plans, especially if SLS doesn't deliver on time and on budget. They can sort of switch over to some of these other ideas. I love this idea from Elon Musk about SpaceX saying, okay, if we just take a spacecraft to the moon and come back to Earth, that will demonstrate to NASA that this spacecraft can go to the moon. Like that's the only way that you can quickly and easily prove to NASA that your spaceship can go to the moon, is to go to the moon, which I think is great. Whoa. Alexander Keith says, I've got a question that I don't know if you can answer. If mass creates a well in the fabric of space-time, what happens when there's no mass, like intergalactic space? Anti-gravity wells? Right. So, I mean, this idea that gravity is actually just a distortion of space-time caused by mass. And so when the moon is going around the Earth, the moon, it's not that the Earth is sucking the moon. It's that the moon is following what it thinks is a straight line, but the Earth, the mass of the Earth, has distorted the space-time around it so that the moon is following a straight line, but that straight line happens to be curved going around and around the Earth. And that's why light can be distorted by mass as well. Even though light doesn't have mass, it's trying to follow a straight line through space-time, and it gets tweaked. So if you're out in intergalactic space, then you're just going to have a lack of distortions of space-time, and so your light is going to travel in a straight line, in the straightest possible line. Now, there's always still going to be mass. You're going to have, I mean, even in the least, the emptiest intergalactic space, you're still going to have a few particles per square meter out there. So you can never really get away from mass completely, but you're just going to have less distortions. And it's really interesting the way astronomers can measure where the dark matter is out there in the universe, is they can watch and see how the light has taken this sort of curving path as it makes its way from wherever it started, like some quasar, to us, as it gets distorted and moving through all of these different blobs of dark matter in the intervening space. And so the less of that there is, then the straighter the line it's going to take. Let's see. Eric Nystrom, what are your hopes of the James Webb telescope? So we're right now, today, actually, there was a press release that said that they have done a successful test of the James Webb Space Telescope's sunshade. So they expanded the sunshade. This is the thing that's going to block the light of the sun so that the telescope can cool down to this temperature, you know, just a few degrees above absolute zero. And the key to this is that it's going to, so it's going to sort of block the light of the sun and block the light of the Earth and block the light of the moon. And that's why it's going to be at the L2 point, is that it's going to be able to put the Earth and the sun and the moon all in the same spot of the sky and block it. And so they tested the sunshade. It's like origami, or it's like 5 layers, and the whole thing had to open up and then come back down. And the test apparently went great. So the next time this is going to happen, they're going to do one more test, sort of their final integration or their final test, just before the whole thing gets packaged up and sent to the launch facility in South America. So right now I'm feeling pretty excited about about the state of James Webb. I mean, so far I haven't heard any more negative gotcha timeline changing events. And I sort of feel like this was what happened with, NASA did a fairly intensive independent review of Northrop Grumman's work on James Webb, and they got to a point where they were like, okay, this, come on, Northrop Grumman, honestly, this is when it's going to be launched, right? And so then they changed the date to this March 2021, but that is the that date hasn't shifted anymore. And so at this point, I think we all feel pretty confident that this is what's going to happen. Flag dude 08. I hope they don't pull a Hubble because there isn't a good way to repair it. No kidding. I can't even imagine, right? Although, I mean, if we were 10 years ago, it would be hopeless, right? If James Webb had launched on time, then it would be hopeless. But now you can kind of imagine there might be some options, right? You might have a chance that Starship could fly out and help get it fixed, or gobble it up and bring it home. Who knows? So, as I mentioned, they put a docking ring on the James Webb Space Telescope. So if they need to, someone can come up with a clever idea. So it's not completely hopeless. It's just like nobody has any plans to do this. There is no missions in the work, but they could. Mike McHugh, is there a finite amount of mass in the universe? It all depends on whether the universe is infinite or not. If the universe is infinite, then there is an infinite amount of mass. And if the universe is finite, then there's a finite amount of mass. And astronomers don't know whether the universe is finite or infinite. LK Raider says, is there a backup James Webb in case something goes wrong with the launch or in space? No, there's no backup. There's no, what do you do with an $8.6 billion telescope that's taken this long to build? It's one of a kind. And if it is destroyed, too bad. I hope you had fun making it. So no, we are all watching with bated breath as this thing flies. A question for people, maybe you can sort of post in the comments, or maybe I should do a poll on the community channel. But I want to do a James Webb episode, and maybe do one before it actually launches. What would be the right point? Should I do it when it's finally boxed up and it's on its way, and then it's about a year away from flying? We're probably a couple more. We've got about 3 more tests for James Webb, and then that's all we'll hear from it until it launches. So maybe that's when I'll do an episode on James Webb, and then obviously one after. But then there will be all kinds of discoveries made by James Webb bit by bit. But I think it'd be interesting to talk about the history, because I'm sure a lot of people don't know the history of the telescope. How long it's been in the works, what are the different iterations that it went through before it sort of reached its current shape and form? What were the big technological challenges that people had to go through? So let me know if that's of interest to you. Dr. Ed Alcott says, so in a zero mass environment, how is time affected? Well, time is not affected. I mean, you experience less time dilation than you would in a high mass environment, if that makes sense. David Reynolds is asking, why does James Webb have to be launched from South America? Great question. From what I understand, the James Webb is going to be launched on an Ariane 5 rocket, which is one of the few rockets capable of launching that heavy of a payload. It is a big, big telescope, and there weren't a lot of launch options. Also, the Ariane 5s are very dependable. So they wanted a launch provider that they felt they could rely on and is capable of lifting that kind of a payload to that kind of, it's not just into low Earth orbit, it's to the L2 point, which is like 1.5 million kilometers away. So it's a tough haul to get a telescope that massive, that far away, farther than geosynchronous orbit. It's a big ask. So that's why they picked the Ariane 5. But I mean, now it's taken so long, right? Ariane is moving on to its Ariane 6. There's the Falcon Heavy. So there are more launch providers now than there were back in the day. Michael, clearly, I do need to do an episode on James Webb. Michael Souza asks, is James Webb only infrared? Yeah, James Webb is a very specific kind of infrared, which is that it is an infrared at the very sort of the longer wavelengths. It's a far infrared. So like the Spitzer Space Telescope, it's a cooled telescope. While Spitzer was cooled, James Webb is going to be extremely cool, like 4 Kelvin, right? So just a few degrees above absolute zero. And the key is that it's going to be able to see through gas and dust, see newly forming planets. It's going to be able to see right out to the edge of the observable universe and watch the first galaxies coming together. It is a phenomenal telescope, but it does a very specific job. While Hubble is like back to that Swiss Army knife analogy, right? Hubble is going to be able to view, Hubble sees in infrared, Hubble sees in visible, Hubble sees in ultraviolet. So it's used for so many different objects. So James Webb is going to do something really specific, while Hubble and LUVOIR, these are more generic, more general purpose telescopes. David Sims is noting, yo peeps, Borisov is going to punch a hole in the ecliptic plane in 5 days. Get ready to patch it up. That's awesome. So this comet 2I Borisov is the one, this new interstellar object that's passing through the solar system. And unlike Oumuamua, we are getting a chance to see it on the inbound, so that we will be able to turn all of our telescopes at it and try to catch it. And I guess in 5 days, it's going to cross the ecliptic. Then who gets a view of it? I guess up until this point, the people in the northern hemisphere have seen it. So I guess this is the people in the southern hemisphere will start to get a chance to view it, because it was discovered by a European astronomer, I think. Anyway, that's awesome. I forget what the closest date of Borisov is going to be, but we will get a chance to get better and better views of it as it gets closer. But actually, Hubble finally took a view at it, which was great. Eric 1, do I think that LUVOIR will actually get built? No. I mean, these big telescopes take longer and longer to get built. We did a video 3 videos ago about these different ideas for space telescopes. And the ones that I really like are the ones that get built up over time. So instead of one big telescope that gets launched and it either succeeds or fails, and then once it's up in space and operating, you're stuck with what it can do, you want... ideally, you want some kind of telescope that you just launch more and more parts to it. And so a lot of these telescopes, the two of them, the Hyper telescope and the Nautilus concept, are both incremental. You launch a spacecraft up and it puts up 10 mini telescopes, and then you launch another one and you get 10 more, and then you get 10 more, and away you go. Yeah, Kerber1 is saying that a Russian guy discovered it. Yeah, I said European, but yeah, Russia. That's like, I think that fundamentally, we are at this really weird time where we're seeing these big launch providers come online. Starship, Falcon Heavy, whatever Blue Origin has planned with their new Glenn and their new Armstrong, whatever that's going to be. So it may very well be that actually we're going to have a lot more the ability to put up infrastructure in space. And maybe we'll go with some of these space-based construction methods for building telescopes. I've reported on a bunch of them. I've seen, a new idea from MIT just came out where they have these tiny little robots that built trusses in space, one after the other. I've got a company that I'm talking to that is 3D printing solar panels in space. And not just like 3D printing the structure of the solar panels, but it's actually printing the solar panels or wants to be able to print them in space. So suddenly you could build space telescopes, or build solar panels and various things in space at any kind of size. So my hope is that people will start to go down this pathway of building these telescopes that they don't start at one size. They are, you add a few, and then you add more, and then you add more, and your telescope just gets bigger and bigger and bigger. Krishna Lockman, will James Webb find out if Planet X exists? And if so, when? Well, I mean, how can we know when? James Webb is probably not going to be the machine that will find Planet X, because James Webb has a very small field of view. You're going to look for something like WFIRST, which has a very wide field of view, or, of course, say it with me, the Large Synoptic Survey Telescope, which is under construction and will come online in a couple of years. It's going to be observing the whole night sky every 2 nights. And so it's going to be finding really faint objects that are moving through the sky. Horizon Brave, what's everyone's thoughts on the Planetary Society? I started listening to their podcast and really like the organization. They seem to be some sort of lobbyist org for pro-NASA support in Congress. Yeah, that's the gist of it. The Planetary Society was actually founded by Carl Sagan and others to advocate for planetary exploration with the government. So they are lobbyists for sure. They are like, when you think about oil lobbyists or gun lobbyists or all kinds of things, the Planetary Society is a science lobbyist. And so they go to the government and they personally talk to all of the politicians and they find out what their positions are, and they craft bills to help more funding go to science projects. And you can be a part of the Planetary Society and you can help fund their work to lobby the government in the United States to make more planetary science happen and specific projects that they think are vital. So, in some cases, lobbyists are the worst. And in other cases, you kind of want them working on your side. So yeah, and I highly recommend the Planetary Radio is a great podcast, and I especially love the Policy Wonk. They do sort of once a month. They do a sort of deep dive into the state of politics and what impact that's having on the space program, because that's kind of the reality, right? Is that is that all of the things that we want in space, the various space exploration, the various space missions, the various science work, all of that is done by government, and the government has to make these laws. And so you want to hear all of the, what kind of budget did NASA get, and which projects have been funded and which ones haven't been funded, and how much is going to go to human space exploration, and what are the requirements for the Space Launch System and all that. And so, I find it really interesting. Stephen Huxtable, thanks for the multiple notifications earlier. Yeah, no problem. I mentioned this at the beginning of the show, but a bunch of you got multiple notifications because I tried to be organized and put permanent dates for all of the live streams that I was going to do. And apparently that backfired, and it put a bunch into everybody's subscription stream, and I don't know what else it did. Like I said, someone from YouTube came to your house and knocked on your door 20 times to let you know that this was going to be happening. So I deleted them all. And now I will just go live and maybe give like a minute notice. And so then you just got to remember 5 o'clock Monday. What am I doing? Is there something I should do on Monday? Park 078, one famous physicist said that we will never be able to migrate to another planet. What are your thoughts? So what you're talking about is that one of the Nobel Prize winners, I forget which one, the one who discovered hot Jupiters, I think, said that we will never be able to migrate to another planet. And come on, that's true, right? Like obviously, we in the sort of meat space that we are not going to be migrating to other planets. The distances involved to go to another planet is incomprehensible. That our fastest spacecraft that have ever been sent are going to take 50,000 years to go to Alpha Centauri, the closest stars that there are. Maybe we can come up with a faster way that will lower that time down to 1,000 years. So then you're going to need to build a generation ship. And then how do we build a spaceship that can keep itself going, all the machinery? And like, if you have people who are born in a spaceship and their only job is to have babies for more people, and their only lives is to live and die on this spaceship on these long journeys. And of course, with the rise of the various kinds of technology that are going on and the rise of artificial intelligence and robotics and computers, I mean, are we going to be us in 100 years? So we have this sort of, I don't know, it's like we have this idea of what space travel is, and it's compared to like what ocean travel is, but it's just not. It's so not. It is such an enormous distance to be able to go. So I think that we will get to a point where humanity is living well across the solar system, maybe. Although again, back to that, what are we going to be? Are we going to be humans? Are we going to be robots? Are we going to be robot humans? But to actually make that journey out to another star system, it seems really, maybe we would want to go. And I guess, if we were able to figure out a way to overcome all of the things that we have, and all the climate change and the asteroid impacts and we are around here for 1 billion years as the sun starts to bake the planet, and we figure out how to move the planet so that the sun doesn't destroy the planet, then yeah, for sure, let's start to think about it, right? If we've been living in the solar system for thousands of years, we've got like living in colonies across the solar system for thousands of years, and human beings are fundamentally unchanged from what we are today, which seems really unlikely to me, then we may want to figure out ways to cross those distances. But it feels, as Cody's Lab is saying, immortal robot body, yes please. Yeah, like it seems more realistic. Like it seems realistic that we will inevitably send spacecraft. We will send robotic spacecraft to other star systems. But it doesn't feel like we will send the meat to other star systems. Maybe we will send seed ships that fly out to other star systems and carry DNA and then print life forms when they get to these other star systems, then use that to seed other star systems with life. But I just can't imagine a practical way that we will do it with just how fragile human beings are and how dependent we are on planet Earth. So I'm with the scientist on that. I don't think we will do it. I think that life will look dramatically different 20 years from now. It'll look really different 50 years from now, and it'll look unrecognizable 100 years from now. If it even, well, I guess that's what that's the singularity. So I don't like to think that far away. I don't tend to think that far into the future. But again, who knows, right? Who knows what's going to happen? We may get to a point where our technology stops and we can't go any farther. Or we may discover some fundamental new kind of physics like stargates or warp drives or that kind of stuff. And then suddenly everything is back out again, right? Now suddenly you walk into a glowy portal and you appear on another planet halfway across the universe. So all I know is that with the kind of technology that we have today, it doesn't seem likely. So, let's see. Last Wish 16, thoughts on a revisited or modernized Sea Dragon. Is there a modernized Sea Dragon? Like, the Sea Dragon was this idea, like, I think back in like the 60s, it was like the biggest possible rocket that was launched from the ocean so that you would minimize the amount of flames and noise vibrations. Then it would take off and just launch an enormous amount into space. But is that better than a fully reusable two-stage rocket like Starship? It doesn't seem like it is. So it feels to me like what Elon Musk is planning is the sort of the ideal. Although, as I mentioned in the Astro Clipper episode, if you can somehow get some sort of air breathing jet system for one part of the flight, if you can take advantage of aerodynamic flight for part of it, you can make the whole process a little more efficient. But a two-stage, fully reusable rocket is really the way to go. Lols dids. If you could visit anywhere in the solar system or the universe, where would you go? Well, in the solar system, there's like too many places to go. I can't even. I would love to see Olympus Mons, like the crater at the top. I would love to see Valles Marineris. I would love to just see some of the crazy cratering and the interesting formations that happen on Mars. I'd love to go to Titan. I'd love to see the seas there of liquid methane. I would love to see the sand that blows around that's made of ice. I'd love to get close to the cloud tops of Jupiter and just see these amazing swirling structures. I'd love to get, pass through the ring plane of Saturn, stand on the surface of Europa or Enceladus. I would love to, see the crazy features on Pluto and Charon. I mean, it just goes on and on and on. And when you think about all of the interesting features that are here on Earth that you've had a chance to see, and you may have some really close to you. Like I have some really beautiful natural landscapes where I live here on Vancouver Island on the west coast of Canada. There's volcanoes that are kind of nearby. There's rifts. We've got these beautiful forests, oceans, blue lakes with icebergs in them. And then you think about how many of these kinds of things there are all around planet Earth, and then you think there are all these things all around the solar system, and then when you think about the universe, and this kind of makes me feel sad that there are 400 or 200 to 100 to 400 billion stars in the Milky Way alone, and each one of those has planets orbiting around it, and on each one of those planets there are going to be features as interesting and fascinating as what we have here on Earth. The biggest mountain, the deepest chasm, the craziest volcano. And we will never know about them, let alone see them. So, makes me sad. It's like all the friends that you never will get to meet, right? Like all you people watching. I'll bet you, most of you, we could sit, hang out. We would be really good friends, but we will never meet. You'll watch me on the internet, but it's different from being all the people who are out there on planet Earth that you could hang out with and be friends with, and you'll never get a chance to. And it makes me sad. So that's why I want my robot body, and then we'll all connect onto the internet and we'll all be friends. Well, doing, he says, you'd freeze to death, Fraser. Yeah, okay, with a spacesuit or a good robot body. All right. That's just a fun question. All the flavors of wine and coffee you'll never taste. Now you're depressed. Easy Tiger says now he's depressed. Yeah, Nancy Graziano says I have so many cyber friends that I may never meet. I feel really fortunate for just the number of my cyber friends that I have met. And my wife did a get together with a bunch of her friends in Italy, like a bunch of her, she's a bug photographer, and a whole bunch of her bug nerd friends all met in Italy and did bug photography for a week. And they had a great time. And I think it's important for us to figure out ways that we can meet in person, to be able to, you meet these people virtually on the internet, but I think it's important to be able to try and figure out some way to be able to cross the planet and to be able to hang out in real life. I'm really fortunate with a lot of the events that I go to. if you go to Dragon Con, you get a chance to see all your cool Dragon Con friends. I'm going to probably go to the American Astronomical Society meeting and meet a bunch of astronomers there. But it's great to figure out ways that you can actually meet people in real life. And I'm really lucky that I have. And that's sort of one of the advantages of my job, is that I get to do that. And for those of you who've gone on trips with me, we did the cruise, we did the, we were in Iceland and a lot of those places. It's such an honor, so much fun. And agreed. And of course, the people who are the patrons, they know that I do interviews after you become a patron. And, we hung out virtually for like half an hour. It's super fun. All right. Independent vote. Friends I'll never meet. Great. Now I'm depressed too. I'm sorry. That's a Canadian sorry. Got about 4 minutes left. Venkatesh Madhavan. Fraser, is there any project that would utilize asteroids as a means of transportation for tourism? I'm imagining a spacecraft with tourists landing on the asteroid and then flying back later. Well, there are no plans for tourism or anything with asteroids right now beyond the occasional way to fly there to visit one. But, going onto an asteroid, it's not like you can use it as a ferry boat. But you can use it as protection. So one of probably the first places that we will try to set up when we go off into space is that we will try to drill holes into asteroids and tunnel in and set up our deep space habitats inside an asteroid. And that'll be a really great way to stay protected. And in fact, one of the ideas with trying to go to another star system is someone did the math on this, that you could take a moderately sized asteroid and you could convert it into spaceship along your journey. You would be able to turn it into water and metal and silicon and aluminum and all of these things that you would require as you make your journey. And so it could very well be that that's what's going to happen, right? Some spacecraft, some self-replicating spacecraft is going to go to an asteroid in the solar system and start building a colony, building a world there, and start to dismantle it bit by bit over time and turn it into a place that's more and more habitable over time. Just turning the raw materials of that asteroid into everything that you require. And that feels like that's like some of the first things that we'll see is, once this technology starts to take off, we will see, that's where I think we'll see the first beginnings of it. And you'll know, okay, great, this is serious, right? We're seeing an asteroid get turned into a space station bit by bit with robotic drilling and 3D printing and various kinds of manufacturing systems. And it'll just be turned, it'll look, every year that goes by, it'll look less like an asteroid and more like a space station. So stay tuned for that. Rupert Adelmeier, sorry. Greetings from Germany. If something like the Starship would land in a shallow methane lake on Titan, what would happen if it tried to take off again? It would essentially be parked in fuel, right? Well, so the problem with methane, with Titan, right, is you don't have an oxidizer. So you might have the fuel side of it, but you don't have the oxidizer side. It's the reason why Jupiter doesn't light on fire. It's made of hydrogen and helium, but it doesn't light on fire because you don't have a Jupiter's worth of oxygen to go along with it. So same thing with Titan. Titan's not going to light on fire unless you bring Titan's worth of oxygen to make the chemical reaction happen. So don't worry about it. Your rocket will be able to take off again. All right. I think we've reached the end of our hour. I apologize one more time to all of the people who got a million notifications from me because I set up a bunch of live events. It won't happen again. And I will see tomorrow. New episode, all about will humanity lose its mind when we discover evidence of aliens? I think not. And then I think I'm working on the next script right now, which is probably going to be Lucy, the new Lucy mission, which has been approved today. So I'm going to just pass a really important design milestone. So we're going to do an episode on that now that it seems pretty serious. So, thanks as always to everybody watching today. Thanks to the moderators. Thanks to our good friends at the Weekly Space Hangout crew and whoever is like watching out on Twitch. That is awesome. So cool that I'm on Twitch. I never thought I'd make it to Twitch. All right. Thanks, everyone. We will see you all next week. I'm going to wait